Have you ever gazed up at the night sky and witnessed the aurora borealis, those mesmerizing, shimmering ribbons of light that dance and swirl above the horizon? These breathtaking displays, often called the Northern Lights, have fascinated people for centuries, inspiring myths, legends, and scientific curiosity alike. But the aurora is more than just a beautiful show put on by nature. It's a living, glowing sign of our planet's deep and dynamic connection to the sun, a reminder that Earth is part of a much larger cosmic system. These lights are created by a phenomenon known as space weather. When charged particles from the sun, carried by the solar wind, collide with Earth's magnetic field, they set off a chain reaction. The energy from these collisions excites atoms high in our atmosphere, causing them to glow in brilliant colors, greens, purples, and reds, painting the sky with light. But space weather isn't just about pretty lights in the sky. The same solar storms that create auroras can also disrupt our technology here on Earth. They can interfere with power grids, cause blackouts, disrupt satellite communications, and even affect the navigation systems we depend on every day. That's why NASA has just launched the TRACERS mission, an ambitious project involving two small but powerful satellites with a very important job to do. TRACERS stands for Tandem Reconnection and Cusp Electrodynamics Reconnaissance Satellites. These twin spacecraft are designed to work together, gathering data in real time as they orbit high above our planet. Their mission is to fly directly into one of the most energetic and mysterious regions of Earth's magnetic shield, known as the magnetic cusp. Here, the sun's energy pours into our atmosphere, and TRACERS will help scientists understand exactly how this process works. By unlocking these secrets, we'll be able to better protect the technology we rely on every day. Everything from smartphones and GPS devices to the satellites that keep us connected and informed. Our modern world is more vulnerable than ever to storms from space. From the GPS that guides us on the road to the power grids that light up our cities, a single solar storm can have far-reaching effects. With the data from TRACERS, we'll be able to build smarter, more resilient systems, protecting our infrastructure and ensuring that our technology can withstand whatever the sun throws our way. So let's embark on this journey together and dive into the fascinating world of space weather. It's time to meet our two tiny satellite heroes, working tirelessly above our heads to keep our world safe. This is science in action, happening right now, high above our heads, as we unlock the mysteries of the universe and shape a safer, brighter future for us all. You check the weather every day, maybe before heading out for work, planning a trip, or just deciding what to wear. We rely on weather forecasts to help us prepare for rain, snow, or sunshine. But did you know there's weather in space too? It might sound strange, but space weather is real and it can have a big impact on our lives here on Earth. It all starts with the sun, our closest star. The sun is far from quiet. It constantly blasts out a stream of charged particles known as the solar wind. This solar wind flows outward in all directions, carrying energy and magnetic fields across the solar system. Luckily, Earth's magnetic field acts as our invisible shield, wrapping around the planet and protecting us from most of this solar wind. Without it, life as we know it wouldn't be possible. But sometimes, the sun gets extra active. During solar storms, like powerful flares or massive eruptions called coronal mass ejections, the solar wind becomes much stronger. These storms can send billions of tons of solar material hurtling toward Earth, and sometimes they break through our magnetic defenses. When these intense storms hit, they can disrupt radio communications, making it hard for airplanes and ships to stay in touch. Satellites orbiting high above us can be damaged by the sudden surge of energy, sometimes even shutting down completely. GPS signals, which we depend on for navigation in our cars, planes, and smartphones, can be knocked out or thrown off course, leading to confusion and delays. Even power grids on the ground aren't safe. Strong space weather can overload electrical transformers, causing blackouts that leave entire cities in the dark. These effects can ripple through our modern world, disrupting everything from banking to emergency services. These aren't just theoretical risks. They've happened before. In 1989, a powerful solar storm knocked out power to millions in Quebec, Canada. Other storms have disrupted satellites and radio signals, reminding us how vulnerable we can be. That's why understanding space weather is so important. By monitoring the sun and forecasting these cosmic storms, scientists help us protect our technology and keep our world running smoothly. And it's not just for scientists. Engineers, airline pilots, astronauts, and anyone who uses electricity or GPS are affected by space weather. It touches nearly every part of our daily lives, often without us even realizing it. By studying how the solar wind interacts with Earth's magnetic field, we can better prepare for the next big storm, develop new technologies to protect our systems, and even learn more about our place in the universe. Space weather connects us all to the cosmos in ways we're only beginning to understand. Sometimes it even paints the sky with beautiful auroras, nature's own light show, created by particles from the sun colliding with our atmosphere. That's why missions like NASA's Tracers are so important. By sending satellites to study space weather up close, we can gather the data we need to predict and respond to solar storms. With these missions, we're learning how to stay one step ahead of the sun, protecting our technology, our power, and our way of life, while deepening our connection to the universe beyond. How do we study the sun's invisible influence? The sun is constantly sending out streams of energy and charged particles, but most of this activity is hidden from our eyes. Scientists at NASA are always on the lookout, using advanced technology to monitor these powerful forces. But to truly understand what's happening, we need to get much closer to the action. That's why we send up our own space detectives, like the Tracers mission. These satellites are designed to investigate the mysteries of space weather and the sun's impact on our planet. Each Tracers satellite is about the size of a suitcase, but don't let their small size fool you. They're packed with some of the most advanced scientific instruments ever built, capable of detecting even the tiniest changes in space around Earth. Their main goal? To study a phenomenon called magnetic reconnection. This is a powerful process where magnetic field lines in space suddenly snap apart and reconnect, releasing huge bursts of energy. It's like a cosmic explosion, and it plays a major role in how energy from the sun reaches Earth. This is how solar wind energy sneaks into our atmosphere, sometimes causing beautiful auroras, but also potentially disrupting satellites and power grids. Tracers will fly through the polar cusp, a funnel-shaped weak spot in Earth's magnetic shield where solar particles can pour in more easily. It's the perfect place to catch magnetic reconnection in action. By measuring particles and fields in this region, Tracers will reveal exactly how energy from the sun gets into our atmosphere, helping us understand the chain reaction that leads to space weather events. What makes this mission truly unique? There are two identical satellites flying in tandem, working together as a team. One satellite measures a region first, then the other follows just moments later. This gives scientists a 3D time-lapse view of what's happening in space, allowing them to see changes as they unfold. This clever approach helps us see how space weather changes not just over time, but also across different parts of space, giving us a much clearer picture of these dynamic processes. With Tracers, we're on the verge of unlocking secrets about the sun and space weather that scientists have been chasing for decades. These tiny detectives could change how we protect our technology and ourselves from the sun's hidden power. Every mission starts with a launch, and Tracers' journey was no exception. On July 23, 2025, after a tense delay, a SpaceX Falcon 9 rocket lifted off from California. Tracers shared its ride with other satellites, including the Large EarthCare mission, a cosmic carpool to space. Once in orbit, the satellites were released one by one. The two Tracers satellites gently separated, beginning their orbital dance above Earth. Years of planning and teamwork led to this moment. The mission team made contact, checked systems, and prepared the satellites for science. This careful commissioning phase ensures everything works perfectly. The successful launch marked a huge victory for the Tracers team. Now, the real adventure, unlocking the mysteries of space weather, can begin. The journey is just getting started. Tracers is the result of a massive team effort, led by the University of Iowa, with Professor Craig Kletzing at the helm. The mission brings together NASA, universities, and industry partners like Millennium Space Systems and SpaceX. It's part of NASA's Small Explorer program, designed for fast, focused science at lower cost. Universities play a key role, not just teaching, but building and leading missions. Data from Tracers will be shared worldwide, letting scientists everywhere make new discoveries. It truly takes a global village to explore space. To solve the mysteries of space weather, Tracers needs the right tools. Each satellite carries three main instruments: ACE, MAG, and EFI. ACI measures charged particles, electrons and ions, flowing through the cusp. MAG is a magnetometer, precisely tracking the strength and direction of magnetic fields. EFI uses long antennas to measure electric fields, revealing how energy moves in space. Together, these instruments give a complete picture of the polar cusp's environment. They're marvels of miniaturized engineering, built for maximum science in a tiny package. With these tools, tracers can finally capture the details of magnetic reconnection. It's the ultimate space detective kit. Tracers is a game changer because of its unique focus and two-satellite strategy. Unlike past missions, Tracers targets the polar cusps, regions never studied this way before. The tandem orbit solves a long-standing puzzle. Is a change in space weather due to location or time? With two satellites, scientists can finally tell the difference. This data will improve our space weather models, leading to better forecasts. More accurate predictions mean more time to protect satellites and power grids. Tracers also shows that big science can come in small, affordable packages. It's a model for future missions, fast, innovative, and hands-on for the next generation. We're entering a new era of space science. Space weather has already caused chaos on Earth. In 1989, a solar storm triggered a blackout in Quebec, plunging millions into darkness. The event showed how vulnerable our power grids are to the sun's outbursts. Even bigger was the Carrington event of 1859, which set telegraph systems on fire and lit up the night sky. If a storm like that hit today, the damage could be catastrophic. Trillions in losses, weeks or months without power. Our reliance on satellites and technology makes us even more exposed. That's why understanding space weather is urgent. Tracers will help us prepare for the next big storm. Science is our first line of defense. The science from Tracers has real-world impact. Its main goal improves space weather forecasting, just like we do for hurricanes. Better forecasts mean satellite operators can protect their assets, and power grid managers can prevent blackouts. For astronauts heading to the Moon or Mars, accurate warnings could be life-saving. With more notice, we can safeguard our technology and infrastructure. Tracers will circle Earth for years, gathering data and helping scientists build better models. The mission reminds us that Earth is deeply connected to the Sun. The more we learn, the better we can live with and prepare for our cosmic environment. So stay curious, follow Tracers' discoveries, and support the science that protects our world. The adventure is just beginning. Our future depends on it.